are going on to meet some of these hidden heroes that are working on space missions and in the space industry and in jobs that you might not have even thought about. And so we're going to be looking at those that are working in science, technology, engineering and maths, and meeting them and having panel discussions with them. And we're about to go over to our first one, which is hosted by Anya. Anya, are you there?
Hi.
Hi.
Thanks for joining us today.
Thank you very much for having me, having the team here, amazing group of people here today.
We can't wait to hear from you all. We're going to hand over to you, and we look forward to hearing your insights in science in space.
Awesome. Thanks, Susie and Fran. Hello, everybody. I am Dr. Anya OBrien. I am a Martian geologist and astrobiologist at the University of Glasgow, and I'm just here to welcome you all to the Science in Space panel. I'll be chairing today. First thing to say is this is a panel discussion where really we want to hear your questions. I have some ideas of things I can chat to these amazing people about, but I'm sure my questions are way more boring than yours. So please, if you've got any questions about space science, about space medicine, about the sun, about Mars, we have an amazing group here today, and anything you want to ask, I'll do my best to put them to the right person, the right expert to answer it. So quickly, just thought I'd introduce myself before I hand over to our awesome panelists. I am a Martian geologist. What that means is I like rocks from Mars. I did a PhD, so that's a degree you do after your first degree, a doctorate. Now it's not a doctor like, in fact, Tamlyn is a more of a space doctor in the traditional type. This is a research project I did for a few years, which really specialised on one topic. And for me, that was all to do with life on Mars. I was trying to understand if Mars has the right building blocks for life. So every little building block that you and I are made of, every cell in your body is made up of things like DNA, and inside that DNA are molecules or compounds. These are little bits of atoms put together, and most of those are all based around carbon. And so if we're going to look for life on Mars, we need to understand, does it have those building blocks, these carbon-based molecules in there? So my PhD was all about searching for those compounds, those molecules in meteorites from Mars. So rocks have been thrown off the Martian surface due to a big impact. They've splashed off into space and then they've landed on Earth. And that was what I did in my PhD. I basically zapped those rocks with X-rays for a few years and figured out some stuff. But that's enough from me in terms of what I've done. The three amazing people we have with us today are Dr. Oyuki Chang. Oyuki is a space weather scientist at RAL Space. This is a government space business in Oxfordshire, and that means Oyuki studies the sun. Then we have Dr. Tamlyn Peel, is a space medicine teaching fellow, so like a lecturer or a teacher at Imperial College London. And then we have Regan, who is a planetary science PhD student at University College London. So that is a very brief introduction, but what I'd like now is for each of our panelists to give you folks a much better introduction to what they do, their career path, how did they get there, and maybe what their favourite thing about their job is. So Dr. Chang, I'm going to pass over to you first.
Hello, many thanks. Well, I'm Oyuki. So I'm working at RAL Space at the moment. I studied my PhD in solar physics back in Mexico. Then I came to the UK with an international postdoctoral fellowship. When I finished my project, which was very specific on interplanetary medium, there was an opportunity to continue working at RAL Space, and I was very, very happy to take it. So what I do is study solar activity and its effect on our planet. So as you may know, the sun is a very, very active star. Its atmosphere is expanding constantly. We call it solar wind. So this expansion that we call solar wind, it's all around our planetary system. So when the sun experiences some kind of explosion in the atmosphere, that will travel out of the sun, and depending on position, that can be directed to the Earth. Now, our planet, lucky us, has a magnetosphere that works as a protection shield for us for this radiation and these very big solar structures. But sometimes this shield is not enough, and this radiation comes into the earth, and then we can see this amazing aurora borealis in the sky in some countries. That's one of the effects of space weather. But also we have our satellites and astronauts that can be at risk. So warning about these possible events is very important. And that's why we are working very hard to try to understand those processes. So that's basically what I do. And thanks for inviting me to this talk.
Amazing. And it's super relevant as well. Many people in the UK, I think just beginning of last week, might have seen the Northern Lights. Down far as south as Oxford, probably people at Harwell at RAL Space themselves might have even seen it. So maybe some of our viewers watching today might have even seen the Northern Lights last week, or perhaps you might have missed it, but you saw it on the news just outside your home because you were asleep. So if you've got any questions about that, about what the Northern Lights is about, how do we see it, I'm just sure Oyuki will be able to help us. So thank you. Okay, I'm going to pass over next to Dr. Tamlyn Peel to tell us about his career.
Hi everyone, good to be here and thanks for inviting me. I'm a teaching fellow now at Imperial College London. So like Anya, I did a PhD a while ago, but I decided that I quite liked teaching other people, teaching students and talking to people about what they're interested in the work, which is in a way more exciting when people ask really good questions. So please do ask questions of us because it's just generally we really like hearing them. I started off when I was a kid, I started off watching things like Star Trek, as I think a lot of people here did. And I had a book about, it was a travel guide to space, which I didn't realise wasn't true, and people hadn't been to Titan yet, so it was quite disappointing to find out it hadn't happened. And I was quite interested in going into space and astronomy, but I wasn't very good at maths, and I found other things to do with medicine more interesting. So I went to university and I studied immunology, which is looking at the body's immune system and vaccines and how we fight off infections. And I found it very interesting, but eventually moved into teaching. I also like going into the mountains and going climbing. So, one of my hobbies is I like exploring out in the outdoors. I'm currently in Romania on a holiday to do some of that. I always liked exploring things, whether it was in the small world or out in the bigger worlds, and space is, the last frontier, as we always talk about. So my job really now is to teach medical students about these extreme environments and what happens in these extreme environments to our own bodies and how we deliver medical care in them. So this might be going up a mountain where there's less air to breathe, or it might be going under sea where it's very cold and there's a lot of pressure, or it might be going into space. So space is a very deadly environment. There's no air, it's very cold. So how do we keep people alive and healthy and not just surviving, but actually functioning in these places is really difficult. We can adapt to these things, so our body goes through processes of adaptation. When we go to altitude, we can get quite sick, but we eventually overcome it. And in space, we can use technology really to help us survive in those and to adapt those environments, including places like Mars, which is quite inhospitable, but we can develop ways of actually keeping people alive and healthy and happy there. So really what I do at university is I teach all these things to medical students to give them a bit more of an idea about what goes on in the human body and for them to understand more, so that when they go and treat people in hospitals, they have a bit more idea of how their bodies can adapt to things. But our students do go on and do lots of interesting projects. So we have some students looking at how dust on Mars or on the moon's surface can be really toxic and quite dangerous to humans. And so how do we clear that? How do we treat that? We've had students go to European Space Agency and do things afterwards. So there's lots of career paths that you can do now in terms of supporting human exploration, and it's only expanding. And so I think it's a really exciting area to be getting into, however you get there, really. So that's me in a nutshell, as I've managed to come full circle back around to doing space stuff after having thought I couldn't get into it in the first place.
Amazing. Thank you so much, Tamlyn. And I think that's, first of all, we've got an amazing message there of, there are lots of different paths into doing space if you're interested in space, but maybe there's one bit of science that you're not the best at, or you're not that interested in. There's lots of different paths available to you, and who knows what route you might end up taking in the future. Space is really for everyone. Okay, so finally I'm going to ask our final panelist, Catherine, to introduce yourself. Please tell us who you are, what you do, and how you got to where you are today.
Hi everyone, so I'm Regan and I'm actually still a student. So I'm in the final year of my PhD. So I think everybody here has done a PhD before. So this is a specialist research project like Anya said. So I've still got about a year left of this. And my specialist research project is looking at dust on Mars. So I'm based at the Millard Space Science Laboratory, which is a department of University College London, but we're out in the countryside. And my research looks at the space environment of Mars. So it looks at the kind of particles that's in space surrounding the planet and how dust storms influence these particles. And I get to use a satellite called Mars Express. And this was the European Space Agency's first satellite to Mars. So that's really exciting. I get to work with the team for that. And I complete my research using a kind of combination of maths and science as well. But in terms of getting into this field, again, I didn't have a kind of direct career path into space. When I was at school, I didn't think I was clever enough to do science or physics. I was told that I wasn't clever enough to do science or physics. So I focused my time on geography, which was my favourite subject, because I really liked volcanoes and earthquakes and learning about what's going on our planet. So that's what I did at university originally. And I really liked learning about volcanoes in particular. And then because of a fantastic teacher, she suggested I used all of the science I've done for Earth volcanoes, but apply this to Martian volcanoes. So I did that in my final year of university, so quite late on, and that kind of kick-started my career into Mars. So I started on Martian volcanoes, and now I look at Martian dust storms and the Martian magnetic environment. So although I didn't do science from the get-go, I'm now a space scientist with more of a geography and geology background.
Awesome, thank you, Catherine. Sorry, I just got distracted for a second there. Like someone just knocked on my front door, but never mind. They can wait. Brilliant. Okay, what I just want to first say is thank you so much to everyone who's already posting asking us questions. I've got lots to work through for our panel here. Going to keep you busy. But please, anyone else, any other questions anyone has? Maybe you've heard mention there about dust and you want to know how does Martian dust affect the body? Things like that. Just keep them coming because I really want to make this as an interactive a session as possible. So I am going to ask a question first of all to Tamlyn. We've got lots of people very interested in being a doctor to do with space medicine, and so I'm going to. We don't know who this is from. They're an anonymous person that's asked, talk about space medicine, please. If one became a doctor, how could you get involved in space and particularly what the UK and I suppose Europe are up to? And I've got a follow-on question after that, which I'll give in a second, that's related to that as well. Thanks, Tamlyn.
Okay, great. So great question for a start. So there are some jobs in the UK already for medical doctors in space. So it's called aviation and space medicine. It's a specialism within the healthcare that you can do. There's only about 3 or 4 of those people at the minute, so it's a very niche environment. So it's talking about people going both on planes as well as further into space. The people in the UK that are interested in these things is the Royal Air Force, so the military, and also the Civil Aviation Authorities. It's the people that deal with planes and plane safety in the UK. But I think it's such an exciting time for getting into these things because, firstly, we're sending humans back into space. We're sending humans to the moon and therefore onto Mars, and there's going to be lots of opportunities for jobs in the future. Certainly by the time you guys are working, there's going to be way more jobs for doing that. I think it's not only medical doctors that get involved in that. So I'm not a medical doctor myself, I teach them, but I'm not one. There's many specialties that they need for doing these things. So a lot of the things we teach is called physiology, so that's how the body responds to different environments. So whether it's exercise or or cold or pressure, these kind of things, knowing how people respond. The other thing that I think is really interesting in terms of space travel is psychology. So how we think, how we feel about being in space. It's very lonely. It's very long periods of isolation with small groups of people who you might not get on with. So actually how we deal, and you can't just come home from Mars. So how we deal with that, how we support people to be in those environments, be happy and healthy is really important. So there's lots and lots of different aspects of the travel into space that we need specialists to help with. So following any of those that you're interested in really is a potential into it. And then UK Space Agency and the European Space Agency can have lots of ways that you can get involved as a student.
Awesome, thanks so much, Tamlyn. I'm going to come back to the next space medicine question in a second, and I'm going to come to Catherine now with one of the questions we've had. So don't think have they got a, yes, no, sorry, again, it's from Anonymous. We can't say who this question's from, but small question for you here, Catherine. We have a question of, do you think there's life on Mars then? And have they found water? Just, you know, your average small question that's not that big deal.
How much time have we got? So do I think there is life on Mars? Yes. I don't want to go into the philosophy of what do we define as life, because again, we could talk for hours about what actually is life. But in terms of kind of bacteria and microbes and microscopic signs of life, I do think we have that on Mars. We haven't found it yet, but I think in the next few years, the next decade, I'm pretty sure we will be finding it. I mean, we've already got tons of rovers on the surface doing fantastic science, looking for life, and we've got more going in the next decade. So I think with this new addition and being able to bring samples of Mars back to the surface of Earth in the 2030s, I think we will be very, very close to finding life. So I do think there's life on Mars, but not aliens, like many people think in sci-fi. And the second question was, have we found water? Yes. OK, so we know there were traces. Well, we know there was liquid and flowing water in the past, because when we look at Martian geology, we can see river channels and we can see signs of glaciers. And this is from looking at the rocks and the sediments. So we look at how the environment looks like. And when we look at some of these images, we say, OK, well, we've got very similar environments here on Earth. So by doing that comparison, we know that 4 billion years ago, or even longer, or even more recent, there was liquid water. And now we also know now there is ice. So we have water ice and also carbon dioxide ice at the poles. So we can see when we look at satellite images, we've got 2 white poles. So we know there is ice there. And some people believe that underneath the surface, there is also ice and running water. So although we can't see any flowing water at the moment, we definitely know there was some there historically, and there might be some under the surface as well.
Awesome. What a comprehensive answer. I'm so impressed. And again, it links back to the idea of it's not just about being straight up physics or whatever. You know, it's kind of like detective work, isn't it? Looking for clues that there's been water on the landscape. And it's especially difficult when we don't have people there looking at it. We've got to rely on the images from satellites and things like that. Amazing. OK, I'm going to go to Oyuki next. We've had some questions about how do people kind of, say if you're a bit younger, you were a school student like a lot of our audience today, how might they want to learn more, explore more? Are there things like work experience you can do at RAL Space? How would you support early career or students even to kind of get into the world of solar science and Northern Lights?
Yeah, well, for that, I think there are many options. I mean, if you're interested in work in space in general, there are like always summer schools for youngest, professors visiting schools, and you yourself can request to visit an institution. I mean, at RAL Space we have visitors all the time, and I'm sure if you send an email, you can arrange something. We have this tour that goes around the facilities. You can talk to people and the staff, and to be honest, it's very amazing because you can see actual satellites and actual instruments from space. Some people can be working on that at the moment that you're there, so you can experience the whole thing, and I think that's pretty nice. So I would say that you always be curious and open your doors as every opportunity that you have, and go to people that is in the field. Ask questions.
Amazing. And I'm just going to go back to Catherine there, because just building on that, you run a project yourself, don't you, that helps people watching, if you are interested in Mars and space, they can get involved. Do you want to tell us about that?
Yes, so I run a project called Eyes on Mars, which is all related to the next Mars rover, which is the Rosalind Franklin rover, which is a European Space Agency mission, which will be going in 2028. So here at the Millard Space Science Laboratory, where I am, we actually built the camera that's going to be sat on top of the rover. And this camera is really exciting because in 2 of the 3 cameras on board, there's a filter wheel. And each of these filters has been designed to take pictures and look at different aspects of the Martian environment. So the Eyes on Mars project is building on this filter wheel and building on the camera. And we have got resources to provide schools with a free activity kit where students can make their own version of the filter wheel. So if you just go on the Eyes on Mars website, if you pop it into Google, it should come up. You can fill in a form and request the activity to be sent to you. So it's all free. We've done the lesson plan, we've done the PowerPoints, we've done worksheets, and we provide all of the physical materials. And this is aimed for ages 7 to 13. So if you'd like to get involved, just pop in a request, send me an email, and I'll happily send out the materials for you to learn more about cameras on Mars.
Awesome, thank you. I'm sure there'll be lots of people interested. And just kind of following on from that, I'm going to ask this to all of you, really. It'd be interesting to have your thoughts on this. We've had a question from Walhampton and Lymington, not sure, sorry if I've mispronounced that, junior school. So they've asked, how old do you need to be to start a career studying space? So I'm interested to what you all think about this. Is at what point do you consider your kind of career in space starting? So Tamlyn, I'm going to go to you first. How do you see it? What age do you think you could start getting interested?
Oh, I think any age. I mean, I couldn't call any part of my job space until probably about 3 or 4 years ago. So it was other things that I was doing. I think the others have shown that you can study one thing and it sort of eventually can tend towards being in space. So I think studying what you find interesting and trying to find a way to make that work for you. I quite like things like the Antarctic as well. I really wanted to go work out there, and I haven't worked out how to do that yet, but that doesn't mean I won't manage that at some point. I think it's keep your eyes out for opportunities, and I don't think it's ever off the table.
Yeah, and that's amazing. That's a really good point, which is that you could be, 12 years old and building rockets, or you could be 40 or 50 and be doing something else completely, but end up working in the space sector. So it's quite different for everybody. Catherine, what about you? How do you see? What do you consider as your career starting?
So in terms of when I started getting interested in space, so not kind of working on it, I would say that kick-started when I was 7, when Doctor Who first came back. That's when I first started getting really excited about space. But then again, in terms of actually working on it and spending my kind of Monday to Friday hours on it, it probably would be my final year of university. So not until I was 20, because that's when I made the switch from Earth volcanoes to Martian volcanoes. So not as early on as when you're deciding things like GCSEs and universities. You can kind of make that switch whenever.
Amazing. And actually, just following on from that, Oyuki, I guess what would be handy to chat about from RAL Space's perspective, do you offer things like apprenticeships for people at RAL Space if they wanted to take a sort of maybe not the same route? Obviously, all of us here are kind of had a university trajectory, but what can RAL Space offer if you don't want to go to university?
Yeah, I mean, from my experience, I think, and I agree with Tamlyn and Catherine, they're like, you can start your career in space at any point. You basically, if you're interested and you have, you collect all the tools you have in your experience, and then you propose something and you say, I want to work in space. And then you say, I have this and that, and I've learned this, and this is my experience in jobs and life and study, education. And there is always a way. I found like people from all kind of backgrounds in RAL Space. So I'm very impressed about that, because if you want it, they will give you the opportunity to show it. So, yeah.
And you yourself, you come to the UK from Mexico. How have you found that transition in working into 2 quite different countries?
Yeah, very different. Professionally, I think the UK gave me an opportunity to innovate and to create things that I've never imagined. And also, I mean, from my background, I've been going and to the space, to another complete different thing. So I was never like into space all the time. It was something that was going and coming. So yeah, after my PhD, when I was able to establish more like science collaborations all around the world, that's when I maybe said, okay, I want to work on space full time. Yeah.
Awesome, thank you. We're going to go back to Tamlyn next with a question, going back to the space medicine thing. We've had a question from Dr. Franklin and 8H, which I presume is the class watching. Hello to you, 8H. Thank you very much for joining us. So they've asked us, if you get unwell in space, do they have the same medicine as on Earth? Interesting question there. Perhaps you can talk to you about different illnesses, or maybe if you're ill, does it affect you the same way in space?
Yeah, it's a really good question because, with the best will in the world, someone's going to get ill in space. I think the first thing to say is a lot of medicine is not about the exciting stuff you see on TV and jumping around and sewing an arm back on. Most of medicine, especially when you're going to these dangerous and remote places, actually making sure people are well enough to go in the first place and there's nothing wrong with them. So actually a lot of it is screening people out, getting people fit, checking for any underlying conditions you might not know about. So are they going to get sick in space? So avoiding having people be sick in space, because it's difficult, and it's difficult in space as it is in anywhere else that's remote in the world. So I think the first thing is that we avoid people getting sick as much as possible, because it's quite difficult. But once they're there, things like the International Space Station does have some medicines on board, and it does have some devices on board to help people when they're sick. So there's a big bag of drugs on the International Space Station that all the astronauts that go up are trained to use. So we don't send doctors necessarily into space with people, because that would be one of the small crew that would go. We make sure that everyone that goes is trained in really good first aid, basically, and then they can phone down to the surface and talk to doctors to help them then diagnose problems and then treat with the drugs that they have. So a lot of these drugs are tablets, but there's also injections and things like that. One of the issues is though that space there's all this radiation going around, and that can make all the drugs break down and stop working. So knowing how long drugs will last in space, knowing how to protect them and when to replace them is a really important part of learning how to do in space, because you're hoping you'll never use them. But you need to update them all the time. And then if there's something more serious, certainly from the International Space Station, we can evacuate people, and that's been done before, and you can be back for a few hours later on the planet's surface. But yeah, if you're on your way to Mars, it's a long trip and you're not turning around. So it's planning for that situation and trying your best to support someone. But if someone gets very sick, it could be very difficult for sure. But yeah, it's a really good thing to think about before you go.
Awesome, thank you. I think that provides a really nice link to Oyuki's work as well, chatting about radiation and the kind of damage it can do. Oyuki, do you want to tell us a bit more about what the risks are associated with the radiation that comes from the sun, and maybe what are the differences between Earth and Mars if you were to travel there? Is there more radiation? Is there less? Can you tell us about that?
Yeah, well, as I mentioned, the magnetosphere is the thing that is protecting us from this radiation in general, As far as I know, because I'm not a Mars expert, but I know that this planet has no magnetosphere as the Earth. It has like a remains of what it was, a magnetosphere. So I don't know how the people that is planning to go is working out this part of the planet, but that would be very interesting. I mean, we've been doing a lot in space already, so I don't think that's something will stop us. Talking about the radiation and the risks in Earth, we're talking about the dependence that humanity has now in technology in space. In the past, it was not that relevant because, pretty aurora borealis all around the globe, that's amazing. But now we have satellites in space, and we depend on GPS navigation, communication, agriculture, banking, defense, basically everything you can imagine is based on satellites now, so it's very important to take care of them. So if we understand sun activity and how it evolved in the interplanetary medium and how that reached the Earth, then we will know, then we will have more knowledge to predict and maybe do some forecast, which is not, we're not in that point at the moment. We're trying to understand more like sun activity and how that works.
Awesome, thank you so much. Just to point out, we have about 8 minutes left, so any more questions, please send them in as soon as possible. We have a question here, which I think probably going to be best for Catherine to begin with. What surprised you most about space and Mars, and what's been the most interesting thing you've learned and most surprising thing? We don't know which people he's from, but there's a lot of people liking it and want to know what you think.
Okay, so for my research, because I look at dust storms, the most surprising thing I learned, and the thing that still amazes me when I research it, is that Mars every few years experiences global dust storms. So a Martian orbit around the sun is roughly twice as long as our Earth year. So a Martian year is about 680 odd days. And it has seasons, but they're about twice as long as ours. And like we have a hurricane season here on Earth and a kind of typhoon season, Mars has a dust season. So this is when the southern hemisphere is in its summer season, and there's lots and lots of activity, and we have lots of regional, dust storms. So these look like kind of dust devils that are really, really large that cover a certain portion of the Martian surface. And every now and again, we don't know why they happen sometimes and why they don't happen other times, but these storms merge together and form one giant storm system. So the whole of the surface of Mars is one singular dust storm. Now, if you Google global Martian dust storms, you can see some fantastic images that have been taken by Hubble and some of the other telescopes and satellites in space, where you see a photo before a global dust storm and you can see different parts of the geology. You can see volcanoes, you can see the canyons, but then during a global dust storm, the whole surface is covered in a haze. You can't identify any of the features because there is so much dust in the atmosphere surrounding the planet. Now, visually, these are fantastic events because they look incredibly beautiful, and they can also cause some bad things, such as killing some of our rovers. So the last global dust storm happened in 2018, and unfortunately, it was this global dust storm that ended the life of NASA's Opportunity rover. So they do have negative effects as well, but I find them really exciting because I'm researching how the atmosphere full of dust affects the magnetic environment and the space around Mars. So I think that's probably the most exciting and surprising thing. And every time I see a new image of these global storms, it surprises me. They're really impressive.
Amazing. And I think that's a nice chance to pop over to speak to Tamlyn now. And tell us, we've heard about these dust storms. They take over the whole planet. That's wild to me, and they go on for ages. Tamlyn, what kind of risks would they pose when we send humans to Mars then?
Yeah, so I mean, there's lots of dangerous things both on the moon and on Mars that they're not happy places to live. So if you're living on one planet, Earth is probably the best place to be. But the dust storms, obviously there's physical damage, they're blowing things around. The dust itself can be quite toxic. So because there's so little liquid water, the dust is quite sharp, and it can cut into things. So if you inhale that, inhaling that dust, if it got any of it into the living spaces, potentially it's quite toxic, it's quite damaging to your lungs, especially if you're exposed to it over time. So if you're living on Mars, you're going to be there for quite a while. So trying to keep that out of the living quarters is going to be quite difficult. So if you've ever been camping and tried to keep mud out your tent, I mean, it's that on an order of magnitude, basically, and just trying to live in those environments. Also, if you're outside, in terms of the damage it will do, exactly you're saying about Opportunity rover, it damaged the rover and killed the rover. Any equipment you're trying to rely on to live there is going to be damaged. So you're going to be out with a dustpan and brush, I think, taking that dust off all your solar panels quite frequently, if nothing else.
Yeah, I don't like the sound of that. I'm renovating my house just now, and I make a lot of dust just from DIY, but I can't imagine a whole planet's worth kicking about constantly. So we have about 4 minutes left until we tie up. So I'm going to ask each of you quickly to tell us in turn, what's the best thing about your job? Like, what keeps you going every day? What do you love most about your job? So Oyuki, I'm going to go to you first.
Yeah, well, the most exciting thing, I think, for me, the opportunity to collaborate with people that is all around the world. So science is international, especially talking about space science. So sharing knowledge with the only intention to understand and to explain how the universe works is amazing. I think that's the best for me.
Awesome, and I completely agree. I think it's really cool to do space work, but for me, it is about the collaboration. It's the amazing people I get to work with all over the world that really makes it. And then, yeah, okay, it's cool to say I get to hold bits of Mars, but to be honest, it's getting excited with other people like Catherine about Mars that is what makes it so fun and what's so great to work on. Tamlyn, what about you? What do you love most about your work?
Well, so I moved to teaching from research. I was doing research before. I was looking at asthma. But I moved to teaching partly because it's really interesting talking to new students every year. Students come up with really good questions. They come up with things that I haven't thought of. And that allows new things to think about how it works. So we always talk about how the human body works in different environments, and we do experiments in the lab. We have some lab space, and working with students to do that, getting the young, fresh minds, as you all are, in to talk to me, is really good. It keeps me on my toes. It means I learn a lot. And I think that's just a really nice experience to be able to do that year on year.
Oh, that's so lovely. And I as a former teacher, before I did my PhD, I taught physics for a few years. I fully endorse that. What about you, Catherine? What's your favourite thing about your PhD?
I think being able to be involved in the kind of current and new space missions is my favourite thing. So I mentioned that I work with the Mars Express mission, so that's celebrating 20 years this year. So a bit like Oyuki, I get to collaborate with researchers across the world that are involved in that mission. But also here in the UK, we're really involved with new missions. So the Rosalind Franklin rover, which is launching in 2028, we are the lead institute here in the UK for the camera on board, and we've got universities across the UK involved in this camera. So although I won't directly be using that for my current PhD, because I'll be finishing in a year, I'm still involved in that science team. So I get to go to meetings at the European Space Agency and be involved with a new mission, which is really exciting and definitely something I kind of pinch myself that I'm able to do every day.
Gosh, yeah, I mean, I can't imagine what it must be like being a literal part of a space mission, knowing you're working on something that is going to Mars, albeit in, you know, a little bit later than originally planned. Okay, so I think that is pretty much it. We've just got 2 minutes. So very quickly, I'm going to give you 20-30 seconds tops, each of you. What is your one piece of advice for anyone watching who would like to work in your field? Oyuki first.
I would say make as many questions as you have. Never keep them.
Awesome. Ask questions. Brilliant. Tamlyn?
Yeah, that was a great one. I would say do what you find interesting. Don't think there's a standard career path. Do follow your interests, and you'll wind your way towards something that is quite satisfying and quite enjoyable.
Awesome. And finally, Catherine?
If you want to get some work experience or ask somebody about how they got into their career, then just ask them, send an email or ring them up, because if they can't directly give you work experience or help you, they'll always, if not, yeah, definitely, if not always, pass you on to somebody that can help you. So just ask for opportunities.
What a lovely way to end. I think there's brilliant advice there, and especially with you there, Catherine. I'm sure all of us here in the panel would be happy if anyone's watching who wants to just have a bit of a chat with any of us about our work. So thank you very much to everyone who has watched. Thanks to my amazing panelists. Next up after our panel is technology in space.